qualitative analysis of organic compounds. For the detection of different elements in the organic compound, we have to do some qualitative analysis. Last session we already discussed about the detection of carbon and hydrogen. Okay. Next, detection of other elements. Okay, like nitrogen, sulfur, halogens and phosphorus. In order to detect these compounds, first we have to do LASSAIGN'S test or preparation of sodium fusion extract. LASSAIGN'S test or preparation of sodium fusion extract. Okay. The different elements are present in their covalently bonded state in the organic compounds. So, first we have to convert them into their ionic state. We have to do the LASSAIGN'S test. Okay. From this we got this extract, and with this extract we are doing different conformation test. First, let us explain the LASSAIGN'S test. First step, take a piece of dry sodium, okay, a piece of dry sodium in a fusion tube and heat it. Next, we have to add a pinch of the substance or the organic compound into it. Pinch of organic compound or the substance is added, okay, and heated strongly. This red hot tube, third step, this red hot tube is plunged in the distilled water in a china dish, okay, in distilled water, plunged in distilled water. Now, next step, we have to boil, cool and filtered, okay, boiled, cooled and filtered. This filtrate is called as sodium fusion extract, and with this filtrate we are doing the different test. First test is test for nitrogen. Okay, let's explain the test for nitrogen. Or detection of nitrogen. Okay, nitrogen. In this, actually in the extract, what will happen is Na plus C plus N, okay, is a covalently bonded these elements gets converted into their ionic form. So here cyanide ion is obtained, okay, in the filtrate. Now next we have to add FeSO4 solution to it, okay, add FeSO4 solution and boiled the extract. To a portion of the extract, we have to add FeSO4 solution and boiled this solution. The following reaction is taking place. FeSO4 plus 2NaOH in the excess of sodium, okay. This gets converted into FeOH twice plus Na2SO4, okay. Next, this FeOH twice on reaction with this NaCN, okay, 6 NaCN, and it gets converted into Na4 FeCN 6 times, okay, plus 2 NaOH. This is sodium ferrocyanide, okay. So sodium ferrocyanide is obtained. Next, we have to cool the solution and add FeCl3, okay. Add FeCl3 to this and some excess of concentrated HCl, okay. Na4 FeCN 6 times, okay. To this we have to add FeCl3, okay. On reaction, this gets converted into ferric ferrocyanide or Prussian blue, okay. Ferric ferrocyanide plus 12 NaCl. Okay, 12 NaCl. This is ferrocyanide or Prussian blue. Ferrocyanide, okay, is obtained. So from the color we can notice the presence of nitrogen, but in some cases sulfur is also present in the filtrate or in the compound. So some thiocyanate will be obtained. This will interfere the reaction, and this reaction will not take place, and the reaction will proceed in some other manner. Let us explain that. Here nitrogen is also present. So in the filtrate, compound obtained is NaSCN, or sodium thiocyanate is obtained. Okay, sodium thiocyanate. So what we have to do? We have to decompose this thiocyanate. Otherwise the Prussian blue, that reaction will not takes place, and the reaction will proceed in another manner. When we are adding ferric chloride, the reaction will take place like this. SCN minus. Okay. Instead of Cn, there will be SCN minus, and the product will be Fe, SCN. This ion will be obtained. Okay. So this compound is blood red color. So instead of Prussian blue, we will get a blood red coloration. This is ferric thiocyanate. Okay, blood red coloration will be obtained. So what we have to do? We have to decompose this thiocyanate ion. For that we have to add excess of sodium. Okay, so the reaction will take place in another manner. NaSCN plus, we are adding excess of Na. So SCN will decompose to sulfide ions and cyanide ions. So the reaction will be like this, plus Na2S. So we will get NaCN. Now we will get the Prussian blue test. The usual test will takes place, and we can confirm the nitrogen and sulfur from this. Okay, this much about the test for nitrogen.